the last episode in the ES6 series. Today we'll be covering ES6 modules. So for historical reference, accessing objects between files has been a particularly challenging problem in the JavaScript world. Until recently, the majority of web applications use global objects. These include things such as window, document, etc., but more specific to your application. This meant ensuring that the file, load order, timing, and objects are all created sequentially in the script. With the introduction of build tools such as Grunt and Gulp, it became a little easier to manage these global dependencies. Files could be loaded in a particular order by using wildcards and injected in an automated fashion into the HTML. It was, however, imperfect. These wildcards could grab all JavaScript files from a source directory, but what if a particular file needs to be loaded to construct an object first? This leads to spaghetti code, which occurs because a given set of files needs to be loaded first, then another, then another. It tied you to a standard file name in order to match those wildcards better, which commonly reflected the framework you were using, tying you closely to that framework. There have been a few solutions such as AMD and CommonJS developed to modularize JavaScript in the past, but until ES6 it was not widely used. To solve this, ES6 standards introduced modules. They are called modules because they are an isolated section of code. Each module is wrapped in an immediately invoked function expression to ensure that no global object bleed occurs. This means that as objects are created within a module, they don't create an object outside of the scope of that module that can be accessed in other files unless you explicitly import them. At this point in time, no browser has native support of these modules. We will be using Webpack and Babel to transpile this code to give us access to the import and export statements. While importing a module, you are basically assigning an object representation of the exported values of a module to a particular variable. If a file does not export anything, it will assign undefined to that variable name. Files will be executed on initial import, meaning if an object is not explicitly defined in the module, but instead constructed, that construction process will execute before assigning it to the variable in the import statement. This means if a file modifies global objects or creates a global object, simply importing that file will generate those global objects for use in later files. So first we'll cover the export syntax. The export statements are actually relatively straightforward. You can export a newly declared variable, such as exporting a const with a URL, or you can export default exports, which you'll see how to import in later features. The default keyword will become important later. So here we're exporting default class. There's no name associated with the class. It's just exporting that particular class definition. You can also mix the use of new variable declarations and defaults. So here we're exporting the default class, but also exporting a const called test with hello world as a string. You cannot, however, export predefined variables without aliasing them under a new name. So for instance, if I state const to export is equal to test, I can't simply state export. Next, we're going to cover the import syntax. What I'm going to call the simple execution import is simply executing the imported script, but not necessarily assigning the output event of that script to a variable. So here you can see import and then the file name. Paths are relative to the file that is importing the module. So in this case, the module is up a directory, and then in the dir directory with file.js is the file. You can actually exclude the .js in your import statement. Since we are importing an object representation of an import, we can destructure the exports of that file. So here we're importing an object, remember, from the file defined and dir file. We're accessing the sum export property on that object using destructuring. If destructuring is not used in the import statement, it will assign the default export to the variable defined in the import statement. So here I say import default export from the file location. That default export that we covered in the earlier slide will be assigned to default export the variable. If no default is defined in that file, the default export variable will be set to undefined. If you want to access the full object that is exported from that file, you can use * as your import. The object will be set to the variable following as in that statement. So here we have import star as module from the file location. So all of the exports available from that file location are stored on the module variable. So all exports, including the default export, are available as properties of the module object. In addition, if you'd like to alias the imported variable as a name, you can destructure the object and use as to alias the properties. So here I'm taking the test property from the export and redefining it as test with all caps as the variable name. These statements can be mixed and matched in an import statement. So here I'm importing test, where test is the default export of the file location, but I'm also grabbing the test support object from that file location. Lastly, we'll be covering modules with Webpack. For the sake of our project, Webpack handles the transpiling. From my previous video, we discussed how to add root directories to our Webpack configuration. This allows us to eliminate unnecessarily duplicated paths, such as node modules for our dependencies and source for our source files. This allows our import statements to be significantly cleaner. Here is that configuration. In addition, we use aliases for those files that are not able to be imported because they're not properly configured in the dependencies package.json. Here we alias reveal, for instance, so that if I were to do an import of the reveal project, it will now function as we intend. You can also use this to rename packages to more convenient strings such as reveal without the tilde. That was ES6 modules. I hope you learned a lot in this ES6 series. Up next will be TypeScript, and hopefully I can get that out in a month or two in its completion. As always, feel free to contact me on LinkedIn or Twitter and comment down below. I always appreciate likes and subscribes as well, and I hope to see you back for the TypeScript series.